Thank you. Thank you, Liz. I'm Merce Crosas from Harvard University and the Director of Data Science at IQSS, Institute for Quantitative Social Science. With our group, we started almost a decade ago now to develop the Dataverse software. That's around 2006, and under my team that has been growing over these last years. The Dataverse was intended, or the reason to build it was very much for the reasons that have been discussed in this session, to have a data repository to enable data publishing or research data and be able to cite it, give credit to the authors and recognition to the authors for citing data, having an infrastructure behind that would help preserve the data, and be able to, in general, just make data more accessible for research, for validation of previous work and connections to public literature. So with that, we started also, after a year or so after that, a Dataverse repository hosted at Harvard. That repository has been growing over these last years, and now it has about 50,000, more than 50,000 data sets. It's the largest general purpose repository that exists at this time. And it's free and open to all researchers for all data types. It started with a focus on social science data. It has grown into other types of data sets. And there is the link here, the data.harvard.edu. You can go and just find data or create a Dataverse and deposit your data sets. So this has been the Dataverse repository is used. Is this the one? Okay. By individual researchers or organizations. Some institutions have installed their own Dataverse repository and have their own institutional Dataverse, but the Harvard one is again open to. Is the only one existing now that is open to all researchers. So I wanted to introduce first what we're doing now with the Dataverse and with a new release that is coming this summer. Because we're very excited about having got, after all these years, a lot of feedback from our community and learned that we were ready to upgrade the technology behind and upgrade the user interface, more importantly, and have a more user-friendly data deposit workflow. And with that, we also added a new functionality to allow better searches, but also extracting metadata automatically from some data formats that we recognize. We've been doing that already for a few years, but now we extended the data formats that we extract metadata from, and those include FITS formats, like Chris was talking, usually used in the astronomy community. Also for any statistical package formats, SPSS, R data frames, Stata, etc., or CSV and Excel formats. We also have we extended the support of metadata, so each data set can have as many files as you wish to upload, but also a very completely extended metadata that includes a high-level data citation metadata, but then also domain-specific metadata. And we've developed a new statistical analysis and exploration tool for tabular data sets that is integrated now with Dataverse. This is, well, as I showed in this previous slide, there is a demo site that shows the new release, but it's still under testing. So the citation metadata is compliant with metadata schemas like data site schema or doubling core terms, or DDI. Some parts of the DDI is another schema for documenting data sets. And that type of metadata can apply to all data sets, and it's important for generating data citation for that data set, but also for discovering that data set and comparing it to others and linking it to the publication. There is also extensive metadata that one can add for social science data sets and humanities or digital humanities data sets, and it's compliant with the DDI schema. We added another set of metadata for astronomy data sets, and this one is compliant with the virtual observatory, the VO schema. Some of the metadata fields in this that are shown here are actually populated from directly extracting information from the header of a fixed file format. So what we tried with all this is that facilitate curation of the data sets by just so there is less manual entry of our metadata, and it's mostly is as much as we can extract it automatically. So we solve a problem with technology because it is difficult for a data depositor to enter everything by hand. So to the extent that it is possible, we do that with all the data files formats that we recognize. One is a data file format that it's not that we're not supporting this way, then the data depositor can add this additional metadata if they want. And finally, here for the biomedical or biometadata, we are compliant with ISO schema, which is the one that Susanna introduced today with scientific data. So when you think about data publishing or data publishing guidelines, I think of three main components, three pillars. One is that you need a trusted data repository to guarantee the long-term access. This might be part of your publishing, of your journal, or might be a community repository like Dryer and Dataverse. Then you need a formal data citation. This is essential, again, as has been repeated in this session, that to be able to link, first to give credit to the data generators, data producers, but also and provide an incentive, basically, to share the data, but also to have a formal way or persistent way to link from the articles to the data set. And then you need, one of the differences between data and traditional publishing is that the data values themselves don't mean very much unless you have additional information, metadata, sometimes code that goes with that data to be able to reuse it, to validate the research that has come out of that data set. So all this together then form what you would say a data publishing framework. With Dataverse, we support this, data publishing with these three components, and we also provide rigorous data publishing workflow that would allows for reviewing a data set when it's deposited, and at some point when it's ready to be released, you can publish it, or that could be the data author or the journal editor, depending where that data set is, if it's in a journal Dataverse or in a researcher's Dataverse. When the data set is published, then we generate automatically this data citation that includes, that follows the data citation principles, joint data citation principles that have been drafted or generated by a large number of organizations. I think I have a link at some point to these to the principles, and I encourage all of you to look at them and endorse them if you feel inclined. So there is, as part of this workflow, then there's, the data is more, keeps living in a way more than traditional publications again, and there will be new versions of that data set that you will need to cite the new version, so we support data citation for the new versions of your data set. Then I'm just going to go a little quickly, I have only 1 minute. So for workflows that we support for integrating with journals, you could either, we're very flexible in the sense that you could either let authors just deposit the data sets directly to Dataverse, and then just provide that data citation to the journal, and link that way the journal article to the data. You can create a journal Dataverse. It's again open and free, and then there are hundreds already of journal Dataverses in Harvard Dataverse. So and you can then provide guidelines to the authors to upload the data set to the journal Dataverse, or you can. We also have recently provided a more an technology integration between journal systems and Dataverse. Since I don't have much time, I won't go into details here, but we've done that with the Open Journal system. It has about 5,000 open access journals that use OJS or the Open Journal system, and now the OJS has a plugin so that if you create a journal in using OJS, you can configure it to deposit the data directly or seamlessly as part of the publishing workflow into Dataverse. With that, we've done this integration in a way that it would follow standards and could be reused and extended for other data repositories or for other journal systems or publishing systems. So we're very, we like very much to extend that to become a standardized common API to integrate repositories with systems. We did it based on the sort specifications API, and is already based on a standardized protocol, so that it's relatively simple, and we can work again with other repositories, hopefully with Riot and others, to follow a similar type of API to provide again an integration between publishing systems and data repositories. Just as a final slide, and this is more than just, this is beyond Dataverse, but it's more of how publishers can work with data, can integrate the publishing workflow with data, how we can convert the publishing framework basically into framework that takes care of or considers data and code and other research products that are part of generating scientific paper. They are part of the workflow themselves, so that from the beginning, when you're providing guidelines to the authors to prepare a submission, you already take into account that they will need to know how to cite data, so you can provide guidelines on data citation. At the time of submission, you can either recommend community data repositories or integrate seamlessly, like we've done with this common API with data repositories, as part of the after the review process or during the review process. You can provide guidelines on how to review data. When the data set and the data and code are published, then you have a data citation that others can reference to, but also they can go and access the data and reuse it, not only validate or reproduce the previous results, but actually extend that research, create new versions of the data set, and that by itself generates new research results that are published again. And I think that way, we will advance science basically by just having this continuous cycle that is living, and it's just non-linear only. So thanks very much. Thank you.